address of the record is stored. The actual record is stored in table, address is stored in index. But whereas in cluster index, the record is stored in index. Okay, it will not store addresses, it will store the row record. Then, okay, now, so next. And one more thing, okay, then. And another point is only one cluster, only one cluster index allowed per table. Only one cluster index allowed per table. Okay, then. So you cannot create multiple cluster indexes. Only one is allowed per table. In customer table, we created one cluster index on customer ID. Yesterday class, we created one cluster index on customer ID. What I'm doing is I11. I'm creating cluster index on customer name. I'm creating cluster index on customer name. Let's see. Error. What? Cannot create what, sir? More than one cluster index on table customer. Drop what? Existing cluster index I10 before creating another one. So because how many are allowed? Only one is allowed. Okay, that. So only one cluster index is allowed per table. You cannot have multiple. And next, one more thing. By default, SQL Server creates what, sir? Cluster index on primary key column. SQL Server creates what? Cluster index on primary key column. When you declare primary key, automatically cluster index is created on primary key column. Okay, then understood. Then so suppose 1 second, drop table what? Customer. Create table what? Customer. Customer ID integer. This is primary key. Customer name what? Varchar of 10. So the table is created. But I not created any index. I declared primary key. See the table. SP help. What's it? Customer. SP help index. This will show indexes created on customer table. You see this? One index is automatically created. This index is created on customer ID, primary key. What type of index is created? Cluster. What type of index is created? Cluster index is created. Okay, now that understood? Now, so automatically that cluster index is created on primary key column. Okay, then now understood? You insert the data, insert into what's it? Customer values. Customer 10 name is A. Customer what? 80 name is B. Customer what? Okay, suppose 40. Customer 40, suppose C. Customer what? Okay, then. So suppose 70 D, like this. I'm inserting 4 records. Okay, na? Then where these records are inserted? Index, not table. That's what. Whatever the data insert, this data is inserted into index. In index, it is inserted like this. 10, 40, 60, 80. 10, 40, 60, 80. Let's say this is 60, suppose. I inserted the data like this. When you insert, the data will be inserted into index. It is inserted like this. Okay, then. Now, let's see. Insert, then. 4 rows affected. See the table? Select star from WhatsApp customer. When you run the query, what it does? It will go to index. It will go to the index and access all the leaf nodes from left to right. Access all leaf nodes from left to right. Actually, which order you inserted? 10, 80, 40, 60. You inserted in this order. But see this, in which order it will show? 10, 40, 68. Why? Because it is not accessing the data from table. It is data stored in index. In index, the leaf nodes are in ascending order, left to right. So 10, 40, 60, 80. 10, 40, 60, 80. Yes or no? Then. Sir, okay, na? Then. So that is why, sir, here in SQL Server, in tables, the data is automatically sorted based on primary key call. In SQL Server, in tables, the data automatically sorted based on primary key column. Why? Here you see that bus, when you run the query, you inserted 10, 80, 40, 60, but it is not showing in that order. It is showing 10, 40, 60, 80. It is automatically sorting now. You are not using order by. Without using order by also it is sorting. In tables, automatically data sorted based on primary key field. Why? Because of cluster index. Because of cluster index. Whenever you insert the data, this data is inserted into index, cluster index. Understood? So 10, where 10 is inserted, left side to 30. Where this is inserted, right side to what, sir? 70. Where this part is inserted, okay, na? Right side to 30. Where 60 is inserted, left side to 70. So in index, the data is in ascending order. When you run the query select start from customer, it go to this cluster index, access all leaf nodes from left to right. So that's why you are getting the values in ascending order. Because this query is getting the data from index. Okay, na? Because data stored in index, data is not stored in table. Understood? Then. Okay, na? Then. Suppose, for example, 1 second again, sir, drop table what? Drop table what's it? Customer. Drop table customer. So table is dropped. Customer ID is, customer name is declared primary key. I declare the customer name as primary key. Let me create it. Okay, na? Then, sir, here, this is K. The name is K. This is what, sir? B. This is what, sir? X. This is D. Which order you inserted? K, B, X, D. Okay, na? Then, so create the table. Table is created now. Yes or no? Insert the data. Table is created now. Yes. Insert the data. Insert the data into this table. Now run the query. Sir, here you created index on what field? Customer name. In index, how the data is arranged based on name, na? Then what? First, what is inserted? B. Leftmost. Leftmost is what, sir? B. Next one, D. Next one, K. Next one, X. Okay. You run the query. You run this query. If you run the query, you see that BDKX. In which order you inserted? You inserted in this order, but it is not showing the data in the same order. It is showing the data in what's the ascending order, name wise. Why? Because you declared primary key, customer name. A cluster index is created on customer name. In cluster index, the data stored in what's the name wise ascending order. Yes or no? Then that's why it is showing like this. So in tables, the data is automatically sorted based on primary key field. What is the reason? What is the reason? Cluster index. Because of cluster index. Okay, then. Next. So another question is, what is the difference between what's a non-clustered and cluster index? What are the difference between non-cluster and cluster indexes? Okay, what are the difference? Hmm. Any doubts here? Hmm. Hmm. Index can be created. Cluster index cannot be created. See, primary key you declared. One index is created. Cluster index is created. You cannot create another cluster index, but you can create normal index. Normal index and customer ID. Possible. You understood? Hmm. If table is not having primary key, then yes. Then if there is no primary key, you can create cluster index. Okay, na? Manually. But if primary key is there, then if primary key is there, automatically it creates cluster index. You cannot create another cluster index. Understood? That means what is the like conclusion is you never come across creating cluster index on tables. Why? Because every table contains primary key. Automatically it creates. What is this is explain understanding. Okay, na? Every table contains primary key. So cluster index is automatically created on primary key column. That means you never come across creating manually cluster index on tables. Understood that now. So non-cluster indexes. Okay, then stores what's that? What addresses of actual records? Addresses of actual records. Where are the actual records? Stored in table. Then cluster index stores actual records. Okay, then next here index and table are what's it? Separate objects, but index and table are one object, not separate. Okay, then needs what's that? Extra storage. Yes, because table is separate, index is separate. It has to allocate the memory for table. It has to allocate the memory for index. But here doesn't need what's that? Doesn't need extra storage because only one object. Okay, na? Then so index itself is storing the table data. Then next one needs what's that? Two lookups. Needs two lookups. Okay, needs one two lookups. One is when you run a select star from EMP where salary equal to 3000, you run a query. When you run a query, first what it does, go to the index, find the salary equal to 3000, take the address, go to the table. So how many lookups? Two. One in index, one in table. Okay, but this needs only one lookup. Needs only one. One lookup. Only in index because index itself contains row. It doesn't need to go to the table. Then fifth. Okay, now. So needs what's it? Two lookups and needs one lookup. It's only one lookup then. Huh? Oh, okay, that is like okay, na? Then Next. Next. Suppose here, by default, it is non-cluster index is created on unique column. Hmm? Again, one second. Drop table, what's it? Customer. Dropping the table. Sorry. Dropping the table. Table is dropped. Let's say customer ID is what's it? Primary key. Customer name. Customer what's it? Email ID. What is paragraph 20? Then what's it? Unique. Suppose I created the table with primary key and unique. Let's see, create table is created. After creating the table, now see, okay, now see the SP, what's her help, SP help customer, SP help customer. See the table. Sorry. SP help what? Index. Okay, to see the indexes created on customer. I not created any, but automatically two created. One is created on primary key field, another is created on unique. What is the primary key field? Customer ID. It is automatically created on customer ID. What is that index is? Cluster index. Another one created on what's that? Email ID. What that is index is non-cluster. By default, non-cluster index is created on unique column. Cluster index is created on primary key column. And then. So by default, SQL server creates what's that? A non-cluster index on what? Unique column. And next, a cluster index is created on what? Primary key column. Understood? Then next one. Web. Sorry. Okay. Then how many indexes allowed per table? Per table. Okay. Na? Maximum indexes allowed per table is 1000. Maximum indexes allowed per table is 1000. Okay. In this, how many clustered? How many non-clustered? How many clustered? One. Only one cluster index allowed per table. Yes or no? Then how many non-clustered? 999. Then so then maximum what's it? Maximum what? 999 non-cluster indexes allowed per table. Then next only what? One cluster index allowed per table. That's okay now. Total 1000. In this one is clustered, remaining non-clustered. That's okay. Then stores what? Address of the actual record, whereas cluster index stores actual record. Indexes and tables are two separate, but here index and table is one because index itself contains the data, table data. Needs extra storage. Doesn't need extra storage. Needs two lookups, but needs only one lookup. By default, SQL Server creates a non-cluster index. And here, cluster index is created on primary key column. Maximum 999, only one. That's okay. So to see the list of indexes, list of what's it? Indexes. To see the list of indexes, SP help what? Index table name, EMP. Then what is this query gives? It gives the list of indexes created on EMP table. I1, I2, I3. What is non-cluster index on salary? I2, non-cluster index on department number. I3, non-cluster index on e-name. Understood? Non-cluster. What this is? Unique. Okay. Then. Understood now? That's it. So it gives which column. You created index on which columns. That's it. So this is about indexes. That's with this SQL is over. Okay, now then SQL is what's it over. Hmm? Then so what you learned in SQL? Huh? What you learned? Commands. Next, joins. Next, categories like okay, commands. Then you learn what's it? Clauses. That clauses are used to perform operations. Next one, functions. Next one, objects. What are the commands? DDL, DML, like DQL, select, TCL. Next one, DCL. You know all these commands. Yes. Next one. What are the clauses you know? Where class, group by. Okay, where? No, 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 no. Sequence. Go one by one. Where after that you learn order by. You learn distinct. You learn top. You learn group by. Next one, group by and what's that? Having. Okay, let's see group by. Next, having. Partition by. Yes. Okay, na? Then, okay, see. What? Partition by. Next one, group by. Next one, having. Next, you learn on class. Where we use it on class? Joins. Okay. Next one, we use it with class. We use it what's that? With class. Subqueries. Subqueries we use it with class. Next, for the operations you learned. Operations. Okay, no? Then data filtering. Data what's it? Filtering. Using where class. Data sorting. Eliminating what's it? Duplicates. Then finding top and rows. Partition by. Dividing. Create. Okay, no? Then to create partitions. Data partitioning. Next one. Data grouping. This is what's it? Data grouping. Having filter groups. To filter what's it? Groups. Next one. Joins. Okay, na? Next one. Subqueries. What? Subqueries. Where class is for filtering. Order by is for sorting. Distinct to eliminate the duplicates. Top is to find top and rows. This is dividing, partitioning. Group by is for grouping the data. Having is to filter the groups. On is for joins. With is for subqueries. What are the functions you learnt? Huh? Okay, na? Functions. What? In operations, you know one more than set operations. Union all, intersect, minus. Yes. Next one. Functions. You know character functions, date functions, numeric functions. Next, aggregate functions. Huh? Sorry, we'll go sequence. Conversion. Okay, na? Next one. You know special functions. Okay. Then you know analytical functions and you know aggregate functions. Aggregate functions. Next one. Objects. What are the objects? You know tables, you know views, you know synonyms, you know sequences, you know indexes. But we learn another one also. We created users, You created users. You created logins. Okay. We created WhatsApp users, created huh? Privileges. Privileges is not a object. Schemas. Something stored in database is called object. Privileges are not stored. Privileges given. Okay. Na? That tables, views, synonym sequence, indexes, logins, user schemas. That's this is what you learned. Hmm. Okay. Na? Then, hmm? Huh? Okay. I'll add it to the Google Glass. Huh? Then. But nowadays not required. Nowadays what? You don't need to ask practice questions, interview questions. You can use huh? uh, chat GPT. Go to chat GPT. Okay. Na? Then so you go to chat GPT. You can ask. Okay. Na? That's what you may suppose. How many interview questions? 100 interview questions on what? SQL. Okay. Na? On SQL. Okay. Na? But which SQL? Then it will confuse. Chat GPT will confuse. You have to everything you have to mention. Oracle SQL. Then like here, if you, for example, if it gives Oracle SQL, in Oracle there is no top class. There is a fetch class. Then you will confuse. That's why you have to mention. Interview questions on what? SQL Server database. SQL Server database. Okay. Then for what? For what's that? 0 to what? 3 years experience. Okay. Then okay. Na? So this is questions. Okay. Then hmm? What are these? All these are what's it? Questions. See that count is not missing. 100. Okay. Na? You said 100 na? Then huh? It is giving questions. But what? Queries, even queries, practice queries. Again you ask. Okay. Then everything is covered. If you can able to answer to this question, that's it. Okay. Then you know na, on delete cascade, this one. Okay. Then see that. What is, you see that just now we discussed it. What is cluster index? What is non-cluster? Difference between cluster and non-cluster. How many cluster indexes can be created on table event? Can table have multiple non-cluster indexes? Yes. What are the disadvantages of indexes? What is composite index? Composite index, you know. Hmm. Okay, then. So this comes in TSQL program. Procedures and what's it? Functions. Okay, then. So again, it is asking, just say give SQL query I will say share them. Copy paste. Copy this, paste it here. Question. That's all. It will give. Okay, na? Okay then. You also go through this SQL. Go through this SQL. Anything is missing, anything you want, then we'll discuss. Okay, na? Oh. Next. What the next one is TSQL. What's that? Programming. Okay, na? Actually, this is also TSQL only. Okay. In Oracle, what's that? SQL, what's that? PLSQ. But when it comes to SQL Server, there is only one. What that is? TSQL. Okay. One is TSQL, what's that? Commands. Another one, TSQL programming. That's all. What we completed is TSQL commands over. Okay, na? Next, TSQL program. There is a separate language in Oracle. One is SQL, another one PLSQL. But in SQL Server, there is no separate, only one. What that is? TSQL. Okay, then. So now let's see. So what is TSQL stands for? Transact SQL. Transact SQL. Okay, then. Okay, now. So, like in this, what are the topics we covered? Then, first, what's it? Basic programming. Then, programs using what's it? Conditional statements. Next one, how to use loops. Next, like how to what's it? Use what? Cursors. Fifth, what? Error handling. Six, what? Stored procedures. Seven, functions. Eight, what's it? Triggers. Ninth, what? Dynamic SQL. That's this is the top. These are the topics. Okay. Okay now. That. Up to now, actually, yeah, up to now, what you did, you executed the commands. But using TSQL programming, what we can do, if condition true, execute update. Condition false, execute delete. That is possible. That is what programming means. You can execute the commands based on condition. If condition to execute update command, but condition false execute what's a delete command. That is possible in TSQL, but this is not possible in SQL. In SQL, you can execute update and delete, but condition to execute update, condition false execute delete, not possible. Yes or no? Then next. Suppose there is update command. There is a update command. There is update command. Okay, then I want to execute this update command 60 times. My table contains 60 rows. I want to execute this update command 60 times. Then what you can do? So what's that? You can take a what's that loop. Take a loop, suppose, then execute update next one. And so execute this command inside a loop. Execute this loop 60 times. If this loop is executed 60 times, update command is also executed 60 times. That is possible in TSQ. SQL plus programming. Understood? SQL plus what's that? Programming features. Then now. So, like, what are the features when you compare with SQL? What are the advantages then? So, TSQL, first one, improves performance. It improves what? Performance. How? How it improves performance? Okay, then. Sir, in SQL, if you go to this SQL, in SQL, like this is okay, then. So, like if we use SQL, okay, na? Then if you use SQL, how many commands you executed up to now? How many commands you executed up to now? You want to insert the data, you submit insert command. You want to update the data, you submit update command. You want to delete the data, submit delete command. At a time, how many commands you execute? Only one command. At a time, how many commands you can execute? Only one. Okay, now that. But when it comes to, suppose in TSQL, in programming, what you can do, see, this is TSQL program. What this is? TSQL program. What you can do in TSQL program, you can group the commands into one program. Whatever the commands you want to execute, you can group all these commands into one program. What commands you want to execute? Insert, update, next one, delete. So execute these commands into one program. Okay, then. So what? Then group these commands into one program, submit this program to SQL Server. That means what is the difference you found? There, at a time you can submit only one, but here you can submit group of commands. You can submit group of commands. So when you can submit group of commands, what the advantage is? Request and response are reduced. Request and response between user and SQL Server is reduced. When request and response is reduced, performance is improved. How TSQL improves performance? TSQL improves performance by reducing the request and response. How request and response are reduced? Because here we can group the commands into one program, we can submit that program to SQL Server. Okay, then. So in TSQL, the SQL commands can be what? Grouped into one block. Block means program. Grouped into one block, and we submit that block to SQL Server. Okay, then. So in TSQL, okay, number of what's that? Request and response between what? User and SQL Server are what? Reduced and performance is improved. Okay, then no need to submit one by one command, submit group of commands. Okay, then next. Okay, na? Then so group SQL commands are grouped into one block, one program, submit that program to server. So in TSQL, request and response between user and SQL Server are reduced, performance is improved. Then TSQL supports what's it? Supports conditional statements. TSQL supports what? Conditional statements. Then what? That means here in TSQL, okay, in TSQL, so let's say TSQL supports conditional statements like what? Conditional statements like if else, if then else, okay, then. So in TSQL, SQL commands can be executed based on conditions. Based on conditions. We can execute the SQL commands based on condition. If condition true, execute one SQL, condition false, execute another SQL. Execute the SQL commands based on the conditions. Okay, next one. TSQL supports what, sir? Loops. TSQL supports what? Loops. How? TSQL supports what? Loops. What loops? While loop, for loop, like that. Okay, then. So in TSQL supports looping statements like while loop. Okay, like what's it? While. So in TSQL, what is the advantage of loops? We can execute the statements repeatedly multiple times. So in TSQL, SQL commands can be executed what? Repeatedly what? Multiple times. So I want to execute update command multiple times. Then keep that update command inside a while loop. Execute the while loop multiple times. Okay, then that's all. Here SQL plus programming. Understood? Then next one. So TSQL supports what? TSQL supports what, sir? Error handling. Supports error handling. Then okay. So what is error handling is? Okay, na? What is error handling? So TSQL supports error handling. Then what is error handling is? Okay. Here you writes, you suppose I create table, what's that? T1 X tiny int. Okay, creating a table is already there. Drop table, what's that? T1. Okay, create the table is created. After creating the table, then after creating the table, insert into T1 values 1000. What happens? Hmm? Inserted. Error. What is the data type? 10 10 takes values up to 255. This data type takes values up to T55. Then given value is what? 1000. What this command gives? Error. Arithmetic overflow. Arithmetic overflow. Okay, na? So what is this is message? Error message. This is a message generated by SQL server. This is a message generated by SQL server. I don't want to show this message. This is a message generated because users, it is okay for developers, not okay for users. Okay, na? I don't want to show this message. I want to replay this message with my own message, a simple and user-friendly message. Okay, then what? So then what you have to do is you have to what's it? Then that is not possible in SQL, but that is possible in TSQL programming. So we can replay this message with our own message. What I want to print? I want to print value exceeding the limit. If you print value exceeding the limit, then user will understand. Next time you'll input correct some less value. Understood? Then so that is not possible in SQL, but that is possible in TSQL. Then what is this is? So in TSQL, okay, TSQL, in TSQL, if any statement causes what's that? error. Statement causes what? Error. If the statement causes error, then we can handle that error. We can handle that error and we can replace what? System generated message with our own message. If any statement causes error, then we can handle that error and we can replace system generated message with our own simple message. Okay, then that is possible. How? With the help of error handling. That is not possible in SQL, but that is possible in TSQL. Fifth one. TSQL supports what's that? Reusable. Programs can be reused. You write programs, that programs can be reused. All this, then this too. Stored projects and functions. What? You call the program, you create procedure. You can call this program from .NET. You write the program in TSQL, you can call this program from .NET. You create a function, you can call the function from .NET. Okay, that is possible in what? TSQL. Okay, na? That. So, TSQL programs can be what? Stored in database. How you are getting the reusability? Because they are stored in database. Okay, na? Then. So, TSQL programs can be stored in database. Understood? Then. Sir, up to now, what you stored in database? Data. Data. Table contains data. You store data in database. Once data is stored in database, what are the advantages? You can reuse the data. Reusing the data means number of applications can access the data. Number of application connect to the database, access the data. Yes or no? So here, then programs can be stored in database. Up to now, you stored data in database. Now we can store programs in database. If you store programs in database, what is the advantage? Programs can be reused. Number of applications can connect to the database, can call the programs. Understood? Then. So suppose, for example, then, see, this is SQL server. This is the database. The database is managed by SQL server. Okay, na? Then. So this is the database and this database is managed by what's it? SQL server. Next one. Then, so what are these? All these are applications. Okay. All these are what's that? Applications. Banking applications. Like suppose here, one is ATM application. One is net banking application. One is mobile application. Suppose all these applications are connected to database, bank database. So this is a bank database that is managed by SQL server. These applications are connected to database. Now, in all these applications, I have a common requirement. What that requirement is? Money transfer. In all these applications, I have a common requirement, money transfer. ATM application is developed by using C#. Net banking application is developed by using ASP.NET. Mobile application is developed by using Android. This is developed by using C#. This is developed by using ASP.NET. This is developed using mobile Android application. Okay, na? In all these applications, there is a common requirement. What that is? Money transfer. Okay, you have to write the code here, money transfer code. You have to write the code here. You have to write the code. In all these applications, you have to repeat the code. Instead of repeating the code in all these applications, you write one TSQL program for money transfer. Where it is stored? Database. You write TSQL program for money transfer, it is stored in database. Once it is stored in database, what the advantage is? The advantage is what? Then, once it is stored in database, then, so what the advantage? It can be called from what? This program can be called from ATM. This program can be called from net banking. This program can be called from mobile application. So all these applications can call this. What is this is called? Reusability. Right? Program, stored program in database, wherever you want, you can call it. Okay? Then. So applications which are connected to what's it? Database can reuse what's it? Can reuse what? TSQL programs. So these are the what's it? Advantages. Okay? Then understood that. So like improves what? Performance. How it improves performance? We don't need to send one by one command. You can send group of commands. Next one supports conditional statements like if else. We can execute the statements based on the condition. Supports loops. We can execute the statements repeatedly multiple times. And supports error handling. Okay, supports what, sir? Error handling. So we can handle the errors, we can display our own message. Instead of displaying system generated message, we can display what, sir? Our own message, user friendly. Supports what, sir? Reusability. These programs can be what, sir? Reused. Write program, store program in database, wherever you want, you can call. Okay, then. So TSQL programs are what? Two types. Or TSQL blocks are two types. Block means program. Blocks are two types. One is what the first one is called? Anonymous blocks. What the second one? What is the second one? Named blocks. TSQL programs are two types: anonymous, named. What comes under named? Stored. What? Stored procedures. Next one, functions. Next one, triggers. So these three comes under what? Named blocks. Okay, then. But what is important for you is this is important. This is not important. Anonymous blocks, what's it? Not important. Not real time. What are real time? Procedures, functions, triggers are real time. But before going to procedures, functions, triggers, you need basic programming. You need basics. Yeah, basic programming means how to write what's it? Basics, how to use statements, how to use loops, how to use cursors, how to handle the errors. So before going to these topics, you need basics. These are the basics. But how you learn the basic? You learn the basics with anonymous block. Okay, na? You learn this with what's it? Anonymous block. Okay, na? So with anonymous block, you'll be learning basic programming, how to declare the variables, how to assign the value. Next one, plus how to use conditional statements, how to use loops, how to handle the errors. Once it is completed, then we'll start procedures, functions, and triggers. Okay, then. So we'll see that in the next class, Monday. Oh, very sorry. Security, the security topic. Actually, it actually will be there in one file. Okay, na? అవసరం ఉండదు. ఉండదు. సీక్వెల్, క్వరీస్, కమాండ్స్, యూ టెస్ట్ కమాండ్స్. ఓకేనా? ఎస్. ఓకే, ఓకే, ఇస్తాను. ఓకే. ఓకే, 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 ఓకే. దట్స్ వాట్. You go through that. Anything is not covered, we'll discuss. ఓకేనా? సీక్వెన్స్ అంటే ఐడెంటిటీ ఓల్డ్ కాన్సెప్ట్, సీక్వెన్స్ ఇస్ న్యూ కాన్సెప్ట్. సేమ్ ఉండదు, కొంచెం సీక్వెన్స్ ఇస్ కంఫర్టబుల్గా ఉంటుంది, కన్వీనియంట్ ఉంటుంది ఐడెంటిటీ కంటే. ఐడెంటిటీ మనం కంట్రోల్ చేయలేం, సీక్వెన్స్ని కంట్రోల్ చేయొచ్చు, రీసెట్ చేయొచ్చు, రీస్టార్ట్ చేయొచ్చు, లైక్ దట్. ఐడెంటిటీ ఎలా యూజ్ చేయాలో చూద్దాం. ఓకేనా? పెడతా, పెడతా. ఎస్, డెఫినెట్లీ. మండే కల్లా అప్లోడ్ చేస్తాం. ఓకే.